मी यशोधन काळे, कोऑर्डिनेट नेट प्रोग्राम. आता तुम्हाला नवीन एका प्रकरणासाठी तुमचं स्वागत करतो. आपण आता ट्रिग्नॉमेट्री हा विषय घेणार आहोत. त्या ट्रिग्नॉमेट्रीचा उपयोग फिजिक्समध्ये, इंजिनिअरिंगमध्ये आणि व्यवहारामध्ये सुद्धा खूप होत असतो. तर आता आपण हे ट्रिग्नॉमेट्रिक रेशोज कसे असतात, ट्रिग्नॉमेट्री कशी, तर हे त्याचा अभ्यास करणार आहोत. The word trigonometry means measurement of a triangle. Trigonometry is an important branch of mathematics. It has various applications in the field engineering, architecture, navigation, mechanics, physics, and several branches of science. Now in this figure, ABI, ACH, ADG, AEF all are right triangles. Angle A is common. We know that in two triangles, if two angles are congruent, then these triangles are similar and the ratios of their corresponding sides are equal. Let us use this here. In triangle ABI similar to triangle ACH, AB upon AC is equal to AI upon AH is equal to BI upon CH. Similarly, triangle ABI is similar to triangle ADG. AB upon AD is equal to AI upon AG is equal to BI upon DG. Considering these two ratios, AB upon AI is equal to AC upon AH is equal to AD upon AG. Now see that AB is adjacent side of angle A. AI is hypotenuse because B is right angle. Similarly, AC is adjacent side and AH is hypotenuse. So these ratios are adjacent side upon hypotenuse, known as cos A. Now IB upon AB equal to CH upon AC is equal to DG upon AD, etc. So IB is opposite of angle A, HC is opposite of angle A, GD is opposite of angle A, and AB is adjacent side. So these ratios are opposite side upon adjacent side, known as tan A, म्हणजे tangent ratio of angle A. Similarly, for the next one is IB upon AI, opposite side upon hypotenuse, is known as sine ratio of angle A. For same angle A, all these ratios are equal. Now see that dotted line and triangle AJE, ADK, ACL, ABM, etc. Now here FE reduced to JE, GK to KD, etc. This means if angle measure of angle A changes, then the ratios are also changes, and therefore again for particular angle A, all these ratios are constant and they are tan A, sin A, and cos A. Here is a origin of trigonometry. Now consider triangle ABC with major angle C equal to 90. Then AB is hypotenuse. We define 6 trigonometric ratios corresponding to angle A as follows. Sin A is equal to opposite side upon hypotenuse. Now consider two right angle triangles ABC and PQR. Here again C equal to R, A is theta, and here also A theta, means these two triangles are similar triangles, and the corresponding ratios BC upon QR is equal to AC upon PR equal to AB upon PQ. So here A upon P equal to B upon Q equal to C upon R. Therefore, A upon C equal to P upon R, etc. Thus, the trigonometric ratios depend on the angle measure of angle. We can construct any right triangle with angle theta. Now, let us see the relation between all these ratios. Relations between the ratios. Consider triangle ABC. Major angle C equal to 90 and measure of angle A is theta. That symbol is known as theta. Now sin theta into cosec theta. Sin theta means opposite side upon hypotenuse, that is A upon C, and cosec theta is the reciprocal of sin theta, and therefore it is C upon A. So A cancel, C cancel, and this product is equal to 1. This means cosec is a reciprocal of sin theta. Similarly, sec is a reciprocal of cos theta, and cot is reciprocal of tan theta. Now see that sin theta upon cos theta. Here sin theta is opposite side upon hypotenuse, means A upon C, and upon cos theta, that is B upon C. So A upon C multiplied by reciprocal of this, that is C upon B, gives us A upon B. So we got one more relation, tan theta is equal to sin theta upon cos theta. Similarly, cot theta is equal to cos theta upon sin theta. Now, by Pythagoras theorem, A square plus B square is equal to C square, means hypotenuse square is equal to sum of squares of remaining sides. That is Pythagoras theorem. So sin A square plus B square is equal to C square. Now sin square theta plus cos square theta is A upon C bracket square plus B upon C bracket square. That is equal to A square upon C square plus B square upon C square. Denominator same. Therefore A square plus B square upon C square, and A square plus B square is equal to C square. Therefore C square upon C square, that is equal to 1. So we got one more relation, sin square theta plus cos square theta equal to 1. And this relation is true for any angle theta. Therefore it is known as identity. So this is the first identity in trigonometric ratios. Now 1 plus tan square theta. 1 is 1 plus A square upon B square. So again B square plus A square upon B square, that is equal to C square upon B square, that is C upon B bracket square equal to sec square theta. So sec square theta is equal to 1 plus tan square theta, that is second identity. Similarly, considering 1 plus cot square theta, we got another identity, that is cosec square theta is equal to 1 plus cot square theta. So we have sin square theta plus cos square theta equal to 1. That is sin square theta is equal to 1 minus cos square theta, and cos square theta is equal to 1 minus sin square theta. Now sin square theta and cos square theta are squares. So and squares are always positive. Therefore cos square theta is greater than equal to 0 and sin square theta is greater than equal to 0. Here 0 less than equal to sin square theta less than equal to 1, because sin square theta is equal to 1 minus cos square theta, means 1 minus some positive number. As 1 minus some positive number is sin square theta, so sin square theta should be less than equal to 1. Now square root of 1 is minus 1 or 1. Therefore minus 1 less than equal to sin theta less than equal to 1. Similarly, minus 1 less than equal to cos theta less than equal to 1. Now next is sec square theta is equal to 1 plus tan square theta, cosec square theta is equal to 1 plus cot square theta. As above, tan square theta greater than equal to 0, cot square theta greater than equal to 0, and sec square theta greater than equal to 1, and cosec square theta is greater than equal to 1. Now let us find the ratios of standard angles. We know that in right triangle, side opposite to 30 is half of hypotenuse, side opposite to 60 is root 3 by 2 into hypotenuse, and in right triangle with angles 45, 90, 90, side opposite to 45 is equal to 1 upon root 2 into hypotenuse. So using these results, we can find out the ratios of 30, 60, 45. Consider this now, this triangle ABC. Here C is 90, A is 30, and AB is twice A, so opposite to 30 is A, and opposite to 60 is root 3 by 2 into twice A, that is root 3A. By Pythagoras theorem, that is AC is equal to root 3A, we got that. Now using definitions, sin 30 is equal to opposite side upon hypotenuse, that is A upon twice A, that is half. Cos 30 is root 3 by 2, and tan 30 is equal to 1 upon root 3. Cosec 30 is a reciprocal of sin 30, so cosec 30 is equal to 2. Sec 30 is equal to 2 upon root 3, and cot 30 is equal to root 3. Now about major angle B. Sin 60 is equal to opposite side root 3A upon hypotenuse 2A, that is root 3 upon 2. Cos 60 is A upon 2A, that is half. And tan 60 is root 3A upon A, that is root 3. Cosec 60, reciprocal of sin 60, that is 2 upon root 3. Sec 60, reciprocal of cos 60, that is 2. And cot 60, reciprocal of tan 60, that is 1 upon root 3. Now ratios of 45 degrees. We know that side opposite to 45 degree in right triangle is 1 upon root 2 into hypotenuse, and therefore if we consider BC is A, AC is A, then AB is equal to root 2 into A. using definitions, sine of 45 is equal to a upon root 2a, that is 1 upon root 2. Cos 45 is equal to a upon root 2 a, that is 1 upon root 2, and tan 45 is equal to a upon a, that is equal to 1. So cosec 45 is root 2, sec 45 is root 2, and cot 45 is equal to 1. Now see that sine 45 is equal to cos 45, and tan 45 equal to cot 45 is equal to 1. Remember these relations. Relation between ratios of theta and 90 minus theta. In right triangle, if one angle is theta and one is angle C90, then another should be 90 minus theta, because sum of measures of angles is 180. So if one is 90, another is theta, then the remaining should be 90 minus theta. So here angle B is 90 minus theta. Now sin theta is A upon C, and cos 90 minus theta is again A upon C. So this proves that sin theta is equal to cos of 90 minus theta. Cos theta is equal to sin of 90 minus theta. Tan theta is equal to tan of 90 minus theta. Cosec theta is equal to cosec of sec theta is equal to cosec 90 minus theta. Cosec theta is equal to sec 90 minus theta, and cot theta is equal to tan of 90 minus theta. Let us note these above results. Sin of 90 minus theta is equal to cos theta. Cos of 90 minus theta is equal to sin theta, etc. Alternative definitions. Now see that in right triangle, angle A is say theta. Then BC is vertical line. You know how to draw graphs. So in graphs, BC is y coordinate, AC is x coordinate, and AB is hypotenuse, say denoted by R. Then sin A is equal to A upon R, cos A is equal to A upon R, and tan A is equal to, that is y upon x. Using these ratios, we'll consider or will modify the definition of sin, cos, tan, etc. because it is required for angles greater than 90. We cannot draw a right angle triangle with one angle 100. Hence the above definition is in a way insufficient. The revised definition is as follows. Now here theta, y, x and 1. Consider radius is 1. So consider a set of coordinate axes and a circle with center at origin, and radius is equal to r. Radius is equal to 1 unit. This circle is known as unit circle. Pxy is a point on the circle. X and y are their coordinates. So y coordinate is Pm, then x coordinate is Om. So we define sin theta as y upon 1, that is equal to y. Means sin of such angle theta is y coordinate. Cos theta is equal to x upon 1. Tan theta is equal to y upon x. So similarly for cosec theta, sec theta and cot theta. We can observe that if PM perpendicular x-axis, triangle OPM is a right angle triangle with hypotenuse OP, and this is equal to 1. OP is equal to 1. The side opposite to theta is PM and the adjacent side is OM. PM is equal to y, OM is equal to x, and OP equal to 1. So sin theta is equal to y upon 1. Opposite side upon hypotenuse. So using this, we can associate coordinates of a point with the ratios. Now consider this figure. Here radius is equal to 1. So coordinates of P point is on x-axis, means its y coordinate should be 0. So coordinates of P 1, 0, and coordinates of Q, they are 0, 1, because Q is on y-axis. So its x coordinate is equal to 0 and y coordinate is 1. Now consider sin 0. OP coincides with OP, means angle between OP and OP is 0 degrees. That is P coordinate of y coordinate of P upon 1, that is equal to 0, and cos 0 is equal to 1. So we get that sin 0 is 0, cos 0 is equal to 1. Similarly at point Q, cos 0 is equal to 1. We know that in the number system, 0 has no multiplicative inverse, that is 1 upon 0 is not defined, means denominator should not be 0, or denominator should be non-zero. So in cosec 0, 1 upon sine 0, that is 1 upon 0, and therefore cosec 0 is not defined. Sec 0 is 1 upon cos 0, that is 1 upon 1 is equal to 1. Cot theta is 1 upon tan theta, 1 upon 0, that is not defined. A ratio of 90 degrees. Now consider this figure. Here P dash, P double dash and P triple dash. Now see that R is constant, means OP, OP1, OP2, OP3, these are all radii of circles, that is a constant term R. And now here angle becomes less. See that OP for this. Now consider this point. Now this is y-axis and this is x-axis. This is y coordinate of P and this is x coordinate of P. As P moves towards this P dash, then y decreases, x increases. Then here again y decreases and x increases. So in tan theta, y upon x, y decreases and x increases, means tan ratio, denominator increases than numerator, and therefore tan ratio decreases. Now in sin theta is opposite side upon this, means y upon this. So when angle decreases, sin ratio decreases, but for cos x upon 1, or this x upon r or x upon 1, now here see that angle increases, then x coordinate decreases, and therefore here if angle increases, then cos ratio tends to 1. So when theta or angle becomes very, very small, then sin theta equal to theta, as theta tends to 0 but not equal to 0. Now cos theta increases as theta increases, so cos theta is equal to 1 as theta tends to 0, but not equal to 0, but it's very, very, very near to 0. Sine of 180. Now this, consider this angle, total this angle is 180. So sine of 180 is 0, and the coordinates of these points are minus 1, 0, because it is on the negative side of x-axis, and therefore cos 80 is minus 1. Now ratios of related angles. Now see that this is a unit circle and O is the center, P is a point. Now this POX is theta, and therefore the coordinates of P are root 3 by 2.5. Now its image in y-axis, this is on the negative side of x-axis, so only x coordinate becomes negative, y coordinates remains as it is. So minus root 3 by 2.5. Now the image of Q is R in x-axis. Now again both these coordinates, they are on the negative side, and therefore minus root 3 by 2 and minus half. Now S is root 3 by 2 and minus half, because S is an image of P in positive direction of x-axis. Now knowing these coordinates of P, Q, R, S, now see that this angle is theta, this total is 90, so this remaining is 60, therefore this is again 60. So 90 plus 60, that is, this angle is 150, so the angle up to this one is 150. Now consider this from this, so this one up to this is 180, then 180 plus this 30 means 210, then up to this, so this is 270. Now 270 plus 60 means that is 330. So using this figure and the coordinates of point P, Q, R and S, we can find out the ratios of 30, 150, 210 and 330. Angle is 60. So these 30, again these 30, then this 60, 60, etc. So this angle is 60. This one is 90 plus 30. Then this one is 180 plus 60. And now this total angle is 270 plus 30, therefore 300. So the angles are 60, then this is 120, this is 240 and 300. Again we know coordinates. Now this is 60, so this must be 30, and therefore the coordinates of P are 1 upon root 2 and root 3 by 2. Now again this is image in y-axis, this is image in negative x-axis, etc. So we got the coordinates as above. We got the coordinates of P, then this P dash, this P double dash and P triple dash. So using this figure and the coordinates of corresponding points, we can find out the ratios of 60, then 120, 240 and 300. Now here this angle is 45. So this is 1 upon root 2 and this 1 upon root 2. Now minus 1 upon root 2, 1 upon root 2, and these angles we can, these coordinates we can find out. So using this 45, this 45, 45, 45, 45 means this angle 45, then this angle is 90 plus 45, that is 135. Then from this up to this 180 plus 45, 225, and this from this up to this, that is 360 minus 45 or 270 plus 45 means 315. Means from these we can find out ratios of 45 degrees, 135 degrees, 225 degrees and 315. Now using these figures and finding ratios, prepare table for angle 0, tan, sin, cos, cot, cosec, sec, etc. up to this 360 degrees. Now prepare this table and from this table draw ratios of noted angles and find maximum value and minimum value of each ratio. Find at what angles ratios are undefined. Find angles whose ratios are equal. So try to answer these questions from the above table and also draw some more conclusions if you can by observing values. Then from these values complete this table. Here quadrants are given. Here x-axis, this is y-axis, this is first quadrant, this is second quadrant, third quadrant and fourth quadrant. Now see the quadrant 1, which ratios are positive and which ratios are negative. Then in quadrant 2, find out which ratios are negative and which ratios are positive, etc. You will observe that in first quadrant all ratios are positive, no ratio is negative. In second quadrant sin negative means cosec is also negative and all remaining are positive. Here tan is positive means cot is positive and all remaining are negative. And here it is C cos positive. So we get that one sentence, one more sentence to remember this. All silver tea cups, all positive. S means sin positive, silver. Then all silver tea, tan positive, and cups, that is cos positive. Now consider examples on all these. Sin A equal to 3 upon 5. Find the remaining trigonometrical ratios. Now see the solution. We got sin A is equal to 3 upon 5. So cosec is a reciprocal of sin. So 1 upon sin A is 5 upon 3. Now we know the identity. Sin square A plus cos square A equal to 1. Cos square A is equal to 1 minus sin square SA. So 1 minus 3 by 5 raised to 2 means 1 minus 9 upon 25. Cos square A is equal to 16 upon 25. So cos A is equal to 4 upon 5. Now sec A is equal to 1 upon cos. So that it is a reciprocal of cos means 5 upon 4. Now tan A is equal to sin A upon cos A. So 3 by 5 upon 4 by 5, that is 3 by 4. Cot A is equal to 1 upon tan A, that is 4 by 3. Thus we have cosec 5 by 3, cos 4 by 5, sec 5 by 4, tan 3 by 4 and cot 4 by 3. Now cot theta is equal to 5 upon 12. Then find the value of tan theta minus sec theta upon cos theta minus sin theta. See the solution. We have cot theta 5 upon 12. So tan theta is reciprocal of cot theta, we know, that is 12 upon 5. Now sec square theta is equal to 1 plus tan square theta. So 1 plus tan square, that is 12 upon 5 bracket square means 1 plus 144 upon 25, that is 169 upon 25. So sec theta is equal to 13 by 5. Cos theta is equal to 1 upon sec theta. Now cos theta is 5 upon 13. Sin square theta plus cos square theta equal to 1. So sin square theta is, transfer this cos square theta on the right side. So 1 minus cos square theta. So 1 minus 25 upon 169 means 144 upon 169. So sin theta is the square root of that is 12 upon 13. Now given expression tan theta minus sin theta and cos theta minus sin theta, substitute all these values. They are 12 upon 15 minus 13 upon 5 and 5 upon 13 minus 12 upon 13. So now here you can find out the subtraction by cross product upon product of denominators, and that is minus 1 by 5 and minus 7 upon 13. So minus 1 by 5 and reciprocal of minus 13 by 7, that gives us 13 upon 35. Find the value of the expression sin square 30, cos square 30, tan square 30, sin sec square 45 and cos square 0. For this we must know the values of ratios of 30, 60, 45, 90 and 0. These are standard angles and these values we should know. Now substituting values of the ratios, given expression becomes, we know sin theta is half, so this is half square. Cos 30 is again half square. Then 1 upon root 3 bracket square, etc. multiplied by 1 upon this, etc. Now 1/4 plus 1/4 plus 1/3 upon 2 minus 1 multiplied by 1/6 plus 2/3. Simplifying this, we get that 5 by 6 multiplied by 5 by 6, that is 25 by 36. Now in this example, A and B are acute angles such that tan of A plus B equal to root 3. Remember that these angles A and B, they are not from the same right triangle, because in right triangle one is right angle and the remaining two, though they are acute angles, in this problem they are not given in the same triangle. It is not mentioned here. So tan of A plus B is equal to root 3 means A plus B equal to 60. Cosec of A minus B equal to 2, that is sin of A minus B is equal to half. Find A and B. Now solution, tan of A plus B equal to root 3. So A plus B is equal to 60. Cosec of A minus B equal to 2, that is sin of A minus B is half, means A minus B equal to 30. Adding 1 and 2, we get that 2A is equal to 90, A equal to 45, but A plus B is equal to 60, therefore B is equal to 15. Find sin theta. Solution, we know that cos square theta is equal to 1 minus sin square theta. The given equation becomes 5 minus 2 into bracket 1 minus sin square theta minus 7 sin theta equal to 0. And we got the quadratic equation 2 sin square theta minus 7 sin theta plus 3 equal to 0. We know how to factorize quadratic equation. So here 2 into 3 means 6. Now factors of 6, they can be minus 6 and minus 1, because minus 6 into minus 1 is plus 6 and minus 1 plus minus 6 is minus 7. So we can split up this minus 7 as minus 6 and minus 1. So we got the values, factors as x minus 3 and 2x minus 1 equal to 0. So x is minus 3 equal to 0 or 2x minus 1 equal to 0, and x is equal to 3 and x is equal to half. But x is equal to sin theta. So sin theta is 3 or sin theta is equal to half. Now we know that minus 1 less than equal to sin theta less than equal to 1 means sin ratio is always between range minus 1 to 1. Sin ratio cannot be greater than 1. Similarly, cos theta is also cannot be greater than 1. So here sin theta is equal to 3 is not possible. This value is impossible. So we should consider only sin theta is equal to half. Now sin 28 upon cos 66 multiplied by sin 24 upon cos 62 equal to cosec square 44 minus tan square 46. We have cos A is equal to sin 90 minus A. Sin A is equal to cos of 90 minus A, or sin 28 is equal to cos of 90 minus 28, that is cos 62, and sin 24 is equal to cos of 90 minus 24, that is cos 66. Therefore LHS becomes, this is cos 62 upon cos 66 multiplied by cos 66 multiplied by cos 62, and these two factors cancel and we get value as 1. We have cosec theta is equal to sec of 90 minus theta. So cosec of 44 is equal to sec of 90 minus 44, that is equal to sec of 46. RHS is cosec square 44 minus tan square 46, that is sec square 46 minus tan square 46, and we know that 1 plus tan square theta is equal to sec square theta, that is sec square theta minus tan square theta equal to 1. So value of sec square 46 minus tan square 46 is equal to 1. This means LHS is equal to RHS. Now consider this one more problem. Square root of 1 minus cos A upon 1 plus cos A. Now we know that 1 minus cos square A is equal to 1 plus cos A into 1 minus cos A. So here we will multiply numerator and denominator by same number, 1 minus cos A. Now this becomes 1 minus cos A bracket square, and 1 plus cos A into 1 minus cos A means 1 minus cos square A. 1 minus cos square A means sin square A, and therefore this is 1 minus cos A bracket square upon sin square A. Now square root of this is 1 minus cos A upon sin A. Now 1 minus cos A upon sin A means every term is divided by sin A. So 1 upon sin A minus cos A upon sin A, that is cosec A minus sec A. Now this is a typical problem and very popular for trigonometry in 10th and 11th standard. Now if sin 5a is equal to cos 4a, find the value of this. Solution, we know that sin theta is equal to cos of 90 minus theta. If sin a is equal to cos b, then b must be 90 minus a or a plus b equal to 90. Now sin 5a is equal to cos 4a means 5a plus 4a equal to 90. So 9a is equal to 90, that is a is equal to 10. So cosec square 3a minus sec square 6a is equal to cosec square 30 degrees minus sec square 60 degrees. But sin 30 is equal to cos 60. Sec 30 is equal to cosec 30 is equal to sec 60. So cosec square 30 minus sec square 60 is equal to 0.